Alright, we're going to talk about how to manipulate equations, or the manipulation of equations. What this means to do is to take an equation that you have, let's say just a random one here. Let's go with b, maybe. Here we are. B squared equals fp plus r. And you look at these random variables here, which you've never seen before, and you have no idea what they mean, and you still can have a pretty good idea of what the equation will come out looking like. And given certain values, actually you can figure out what the k value and b value at least should be. Alright, so we're going to start over here by looking at the generic or the general equations of the four basic functions that we talked about. Linear, which of course will make a straight line. You have the parabolic, which will make a parabolic line. This one here, it looks a little bit weird here, but this is, this whole thing is just k over x. So that's going to be your hyperbolic, and then in here this is just it says x to the 1/2. So again, this is k square root of x, and that's going to give you your square root function or your weak Nazi, depending on what you want to call it. Anyway, so you'll notice that just by looking at these general formulas, okay, that k doesn't necessarily have to be a number. It's whatever constant is multiplied next to the independent variable. And the independent variable could be taken to the second, or the reciprocal, or the square root. But whenever k is right next to it, that is what your k value is. And your b value is going to be whatever is added over here on the side. Okay? So, given what the y and the x value should be, we should be able to figure out what where everything belongs. Alright, so let's start off with this. Let's look at this formula right here, and let's say I wanted to figure out, let's go just f versus p. When I say this, what I'm telling you is I'm telling you your dependent variable, or your y, and your independent variable, or your x. What this starts off telling you is that my dependent variable should try to get by itself into the first power, because that's, as you see right here, always the way that we set it up so that we can figure out what shape it's going to make. So in this right here, I'm just going to do some basic algebra. I'm going to have b squared minus r is equal to fp, and then I'm going to divide by the p on both sides. Alright, just realize that I've accidentally started off with kind of a complicated one, but that's okay. So the first thing I'm going to look at is, okay, my dependent variable is over here by itself, which it needs to be, and now I'm going to look at what is my independent doing, and that's actually 1 over p. Or if I break this down with algebra a little bit simpler, it says b squared minus r times 1 over p is equal to f. So now what you're going to do is you're going to give a sketch of what this function should look like if you were to graph it actually in a lab. You start off by putting your variables. My f is my dependent, so it goes on right there on the y-axis. My independent is p, so it goes here on the x. And now I need to look at what general shape is it going to make. Well, it's going to be the 1 over p, so that's the 1 over x, so it makes hyperbolic shape. That's a terrible hyperbolic. Now we need to figure out what is my k value and what is my b value, or what is my y-intercept here. Okay? My k value, once again, is going to be whatever is multiplied next to. Now, this is a tricky problem because you see the subtraction sign here. You might say, oh, then that needs to be an r, but notice how I can't pull that out. I can't pull an r out without pulling the p out, and I need the p to be 1 over p, or by itself. So this has to be multiplied next to it. So my k value in this particular instance is b squared minus r. My b value, or my y-intercept here, should be whatever is added next to. There is nothing added next to this whole term, and so my b value, or y-intercept, is 0. Let's look at another example. Okay, let's look at two examples that we ended with today. Maybe you didn't get to them. So again, we start with an equation that you've never seen before. Remember that when you have an independent variable here, that of course is going to change, and your dependent variable is going to change as well. But since we're in science class, even though you see these listed as variables because they're letters, these other two right over here are going to be held constant the entire time. Now this is a difficult concept for some people to get over, but these are exact numbers or represent exact numbers. G might be 4 and W might be 12. So even though they look like letters, the combination of that represents 48 or some very specific number. Okay? So when I say the K value is GW, what I'm really saying is that these two values multiply together, that GW is 48, and that is the constant. Okay, so in this equation, again, we have to make sure that our dependent gets by itself. So we have E equals the square root of BGW. Okay, so again, what we do is we look at, okay, I've got my dependent by itself, so what is happening to the independent? And you can see very clearly here that the independent, or B, is taking the square root of, and so it's going to make this shape. Now you do have to be a little bit careful with the square root function, in that you might say that the K value is GW. Okay, so we might say here that E goes here, B goes here, it's a square root, and you might say that K is equal to GW. That's actually incorrect, and the reason why is if you look at this mathematically, this is also equal to the square root of B times the square root of GW. I just can't pull GW out randomly here. So actually the K is not GW, the K is the square root of GW. So once again, K is whatever has to be multiplied next to the independent variable. And my B value in this case, which is kind of confusing because I have a B variable, apparently I keep doing that, is going to be 0 because there's nothing added on to this term. Let's look at this last example. I have this weird equation here, and I could choose any of them in here. You right now could choose two variables, and of course it's going to make the shape look a little bit different. It's still the same equation, but in this particular case, I'm going to go with I and L. Okay, so now and again, we get I by itself. In order to do that, I'm going to take I is equal to, I'm going to subtract that over, so it's L minus GN minus B9, and then divide the whole thing by X. Now you have to divide the whole thing by X, or I could do this. I'm going to put 1 over X over all of these, because this is the exact same thing. And you'll see why here in just a minute. Now, once again, we see that the dependent is by itself, so now I just look at what is happening to my independent. My independent is the L, okay? And you can see here that L is to the first power. Now you might be confused because it's being divided by something, but remember that thing that's divided by is just a constant. So if I show someone what this is going to make, what sketch it's going to make, I have I over here, L, and it's going to make a straight line. Now I'll start off with what is my K value? What's multiplied next to it? Well, what's multiplied next to it is, well, that's subtracted, that's subtracted. The thing that's multiplied next to it is 1 over X. So there you go, there's my K. And my B value, or my y-intercept in this case, is what is added next to it. So make sure you're careful with the subtraction sign, because the answer is negative GN over X minus B9 over X. What this does is, once I know the value of these from probably measuring them in the lab, I can get an exact value of B. I can do the same thing for K. Then once I get my final equation, actually plotting the I and plotting the L, okay, once I do this and get these dotted points, and I do my whole find the specific equation of that line, and I find my K, and I find the exact number of B, I can compare them. I can say this K is supposed to be whatever 1 over X is. So if this is, say, X is 10, then it should be, my K value should be 0.1. So I know ahead of time what that K value should be. And let's say I figured all this junk out as well, and it ended up being, 4. I can check my B value to see whether or not it's 4. And if it is, I can tell that the graph in the lab represents very much what I expected it to, given this weird equation over here. And that's the point. Again, the point is to tell ahead of time what shape should it make, so that way when I figure out the shape, I can compare. And I can say, this is what I expected, this is what I got. They're very similar. So it probably means that this equation is in fact true.